Good afternoon, students. So yesterday we have started the vector calculus. That is the sixth semester elective B paper. It is. So in that we have seen what is a vector calculus and what are the vectors and what are the scalars. How you will identify them and how the vectors are represented and also how the scalars are represented and even types of vectors we have seen. In that I have defined different types of vectors and even we have seen the algebra of vectors. So algebra of vectors in the sense it is the addition of the vectors and subtraction of the vectors. And if it is a multiplication of the vectors means we have the cross product is there and also dot product is there. Cross and dot product, two products is there. There is a multiplication of the vectors. So it is in the unit 1. And we have seen some problems on collinear and coplanarity, showing whether the two given vectors are collinear or coplanar. Okay. So in addition of vectors, triangle law of addition and also parallelogram law of vector addition we have seen, and also properties of vector addition in that commutative law and also associative law we have seen. So these all concepts are completed. And two example problems on coplanar and collinear also we have seen. Okay. So yesterday I have told about the dot product. That is the dot product of two vectors is equals to A dot B. Vector A dot vector B is equals to mod A into mod B into cos theta, and theta lies in between 0 and pi. Okay. This is the theta value, and we'll take the theta values as the smallest non-negative angle. Okay. So one is the largest angle will be there, one more will be the smallest angle will be there. So we'll take the theta as the smallest non-negative angle. Okay. And also dot product of, whenever we'll do the dot product of two vectors, the resultant whatever you will get, that it will be a scalar. Okay. Even I have mentioned that one. And the dot product of two vectors is also satisfies the commutative property. Okay. And even condition for orthogonality also we have seen. The condition for orthogonality or perpendicularity. Dot product will have the perpendicularity, that is A dot B equals to 0 here. That means theta value will be pi by 2. So cos 90 is 0. No? So A dot B equals to 0 you will get. Two lines are perpendicular, that is at the angle 90 degrees you will get. So theta will be pi by 2. So, and even you remember this formula, that is a condition of orthogonality or condition of perpendicularity is A dot B equals to 0. Okay. And even I have told that is a negative of a vector. If the two vectors are parallel, then A dot B equals to, you will get the cos 0 degrees theta. And another one is if that is whenever the two vectors go in the same direction, you will get theta value as 0 degrees. And when they go in the opposite direction, you will get the theta value as pi. So cos pi value is -1. So we will get the whatever the resultant is there, A vector A dot vector B is equals to, that is mod A into mod B. For the same direction you will get, for the opposite direction you will get minus mod A minus mod, that is minus mod A into mod B. Okay. So up till here we have covered yesterday. And even length of the vector also we have seen. That is the length of the vector is. So length of vector is. So length of the vector or else the magnitude of a vector, both we can take it as the same. So if A vector A is any non-zero vector, so A dot A, that is length of the vector, we call it as A dot A is equals to. So A dot A means it is in the form of A dot B. So A dot B means what is the formula? A mod A into mod B. What is our B here? B is A. And here when we are finding A and A, you will get here cos theta value as 0. So cos 0. So cos 0 is 1. So mod A into mod A is equals to, that is mod A square. So length of the vector A is equals to length of, so these all you will get for objective type also. Vector mod A is equals to, that is modulus. What is the modulus or magnitude means under root of whatever the vector values are here, ijk values, those we have to do the square of that one. Here you are having only vector A, so it is A square. So it is equals to root A dot A. Okay, or else we can write A square and both will get cancelled, so you will get the same one. So this is the length of the vector. After that, angle between the vectors. Just now we have seen the formula. No? That is angle between vectors. That is A and B. Vector A and vector B means we have formula is vector A, vector B is equals to mod A, mod B cos theta. Okay, so angle between these two vectors is, this is the angle, no, cos theta. So take here cos theta is equals to vector A dot vector B by mod A into mod B. So we need theta value. So theta is equals to cos inverse of vector A dot vector B by mod A into mod B. Okay. So like this on this you will have 5 marks problem also, angle between the two vectors. So two vectors will be given. So it will ask to find the angle between the vectors. So we need to remember the formula, that is theta is equals to cos inverse vector A dot vector B by modulus of A and modulus of vector B. So here vectors means put the, you can write here like this bar or even put the arrow mark like this. Okay. So next is up till here we have completed the concept of A dot B. Next we have the cross product is there in multiplication of vectors. So whenever we do the cross product, or we call it as a vector product of vectors. Cross product or vector product of vectors. So usually we'll use in the problems it as a cross product. So cross product, or it is called as vector product of vectors. Okay, for cross product in the sense A cross B, it is equals to determinant of A, determinant of B sin theta into n. So n vector here, whatever it is there, it is a unit vector and it is called as a cap. So cap represents that it is a unit vector and it will have the value as 1. So cross product is A cross B is equals to modulus of A vector into modulus of B vector into sin theta. Okay, whenever n value will take it as a 1. Okay, and even theta lies in between 0 and pi. Okay. Okay, theta is angle between A and B and n is the unit vector. Okay, theta is angle between vector A and vector B and n cap. N cap is unit vector. Okay, so these are is a unit vector perpendicular to the, if you remember n cap is a unit vector, it's enough. Okay. So for dot product, you will have the condition of perpendicularity. For cross product, you will have the condition of parallelism. Okay. So this is the important one, condition for parallelism. Parallelism. So condition of perpendicularity is what? A dot B equals to 0. So here condition of parallelism is A cross B equals to 0. Okay. So if A and B are collinear, then if vector A and vector B are collinear means they lie in the same line. Okay. Then theta equals to 0. So theta equals to 0 means if you substitute here theta value as 0, what you will get? A cross B is equal, sin 0 is 0, no? So then A cross B is equals to mod A mod B sin 0. So you will get this as 0. Or equals to 0, or one more is sin pi is equals to 0. So theta may be 0 degrees or else pi, that is 180 degrees. Sin 180 degrees is 0 and even sin 0 value is 0. Okay, so the angle may be 0 or 180 degrees. So you will get the condition for parallelism, that is A cross B is equals to 0. So remember that one, that A cross B, vector A cross vector B equals to 0 is the condition of parallelism. A dot B equals to 0 is the condition for perpendicularity or orthogonality. Okay. So, and even we have seen yesterday, that is I dot I is equals to 1, J dot J is equals to 1, K dot K equals to 1 value. And if you have other vectors, that is I dot J, means you will get 0, or J dot K equals to 0, or K dot I is equals to 0. Okay. And in cross product, you will have that I cross I. So is equals to 0. So that is the difference between dot product and cross product. That is I cross I equals to 0. And J cross J, so put here vectors. And K cross K equals to 0. Okay. And where for what values you will get to means I cross J is equals to K, you will get is equals to vector K. Next to J cross K is equals to vector I. And after K, you will get K cross I is equals to J. Okay. These are the positive values. And if you just interchange this one, that is J cross I. So you will get as minus K vector. And here K cross J means you will get minus I. And I cross K is equals to minus J. So remember this while solving the problems. These are useful. So these 6 are important, and these values, that's why in cross product, when you will do the I cross I, that value will be 0. And when you will do I cross J means that will become K, and J cross K equals to I. So these are important. And problems are there on dot product and also cross product. Yesterday, 2 problems we have done on collinear and coplanarity. And another one is show that the vectors, 2 given vectors are orthogonal to each other. Okay. So orthogonal to each other means the condition for orthogonality is A dot B equals to 0. Okay. So in that you have to substitute what is A and what is B, and you have to do the dot product of them. Then you will get the value, whatever value you will get, that is the means they should be equal to 0. Then the 2 vectors are orthogonal or perpendicular to each other. So before that, we'll see how to find the dot product. So if A equals to, example problem, if vector A is equals to I plus 2J plus K and B is equals to 2I plus 4J plus 5K. Okay, then find vector A dot vector B. Okay. So we have to find the value of vector A dot vector B. So you can write the given vector A equals to vector B. Then you write vector A dot vector B is equals to what is vector A? I plus 2J plus K dot 2I plus 4J plus 5K. So dot product means I dot I value is 1, I cross J value is 0, I dot J value is 0, I dot K value is 0. So only whatever the 1 values you are getting, I dot 1, J dot J and also K dot K. Those values only you multiply, other values automatically they will get it as 0. Okay. So I dot I. So that value is 1. So 1 into 2 is 2. Next plus this is 2 plus 4 is 8. Next here 1 is their quotient. 1 into 5 is 5. So you'll get the answer as 15. So dot product, whatever the resultant you will get it as a scalar. This is the scalar, no? You are getting some value. So whenever we'll do the dot product of 2 vectors, you will get the resultant as a scalar. Whenever you do the cross product of 2 vectors, you will get the resultant as a vector. Okay. So this is the how to find A dot B. And if similarly for this only you can find what is A cross B, or for any other problem also you can take. So if you find, I am writing here only find A dot B and A cross B. Okay, for this only we'll do. So A cross B means So first, whatever row will be there, you write that row as ijk, vector I, vector j, and vector k. And for A, whatever the quotients of I, j, k are, you write them. So 1, 2, 1, and this is 2, 4, 5. Okay. So when you find the determinant of this one, so determinant, I hope so you know already in 5th semester, you have seen the Cayley-Hamilton theory. In that you have seen the rank, how to find the rank, and that you have the concept of determinant. Okay. So this column and this row, if you eliminate whatever the minor is there, if you cross multiply that one, you get the cofactor of I. Okay. So 5 2s are 10 minus 4. Next one is minus j into, if you eliminate this column and this row, 5 minus 2 and plus k vector into 4 minus 4. Okay. So 10 minus 4 means it is 6i. 5 minus 2 is 3. So minus 3j. And here 4 minus 4 is 0. 0 into that vector means we'll get 0 value. So 6i minus 3j is the resultant vector of A cross B. So whatever the resultant vector is there, this is the vector. And A dot B means you will get the scalar. Okay, this is the difference between dot product and cross product. Next, another one is show that the two given vectors are mutually perpendicular, or else you may call it as a orthogonality. So the condition for that is show that the vectors show that this is the problem you have in your textbook. It is there. Show that the vectors somewhere in the MEQ or it is there. So he has not given A. It has 9a plus j minus 6k and 4i minus 6k plus 5k are orthogonal. Okay, show that the vectors, the two vectors are orthogonal. So first thing you have to remember what is the condition of orthogonality. If you know that, then you can find the answer. So first to take the given vector as A and the second vector as B. Let vector A is equals to 9i plus j minus 6k and vector B is equals to 4i 6j plus 5k. Okay. Now, if A and B are at right angles, or the condition of orthogonality is so orthogonality is that A dot B is equals to 0. Okay. Our condition of perpendicularity, our two vectors are mutually perpendicular to each other, also the same condition. So therefore, A dot B means A dot B is equals to 9i plus j minus 6k dot 4i minus 6j. So see whether you are getting 0 or not. 9 4s are 36. So plus minus. Here 6 is there. 1 into 6. Next minus 6 5s are 30. So minus 30 minus 6 means you will get minus 36. Plus 36 minus 36 means it is equals to 0. So it is satisfying the condition of orthogonality. Therefore, vector A and vector B are orthogonal. Okay, this is the problem. Like this problems you will get for the 5 marks. And next one is find the volume of the paralleloid whose edges are given by the vectors. 3 vectors are given. You have to find the volume of that one. Okay. So volume of the paralleloid, whatever formula is there, it is the triad of, that is triple triad of vector A, vector B, and vector C. Okay. So this you will see after the concept of the triple product you have. Next one. Next, another one is finding the projection of vector. Projection of the vector A on the vector B. So next one is find the projection of the vector A on the vector B. You see the question number from the textbook. Find the projection of the vector A on the vector B. So many formulas are there and also many concepts are there in the unit 1. So check from the textbook. So whatever are the important topics, they stand covering them. Where A vector is equals to 2i plus j minus k, and B is equals to minus 6i plus 2j minus 3k. Okay, these are the two vectors, and we need the formula for finding the projection of a vector. So for that one, the formula is projection of A on B. That is the projection of vector A on B is equals to, that is vector A dot vector B by modulus of vector B. Okay. So two types will be there. One is projection of A on B, and second one is projection of B on A. Okay. Next one is projection of vector B on A. It is equals to, same you will have vector, that is A dot B by, but instead of in the denominator B, you will have A. Okay, remember these two formulas. Slight only denominator is different. When A on B, you will have vector B here, and here you will get vector A. So our question is vector A on vector B. So therefore, projection of vector A on vector B is equals to A dot B. So A dot B means vector this one and this one dot product. That is 2i plus j minus k dot is minus 6i okay. So able to see this, and divided by modulus of B. Modulus of B means it is under root of minus 6 square 2 square plus minus 3 whole square. So it is equals to 2 into minus 6. So you will get it as minus 12. Next it is plus into plus 2 you will get. Next minus into minus means plus 3 by, it is 36 plus 4 plus 9. So 36 plus 4 means 40. 49 means 49 is 7. And 3 plus 2 is 5. And it is minus 12. 5 minus 12 means we get minus 7 by 7. So we get the projection of vector A and vector B is equals to minus A value, minus 1 value. Okay. So like this, you have to find the projection of a vector A on vector B or on A. Okay, formulas are, these are the formulas. And next we have the concept of, that is, we have seen the dot product conditions we have seen, and cross product we have seen, and A dot B and B dot A. So next, product of three vectors means if three vectors are given, vector A, vector B and vector C, then how to find the product of them. So with the help of that only we'll find the volume of the parallelopoid. Means in volume of parallelopoid you have the three vectors will be there. So with the help of that we find the value, or it is called as a triple triad also. Means vector A is there, vector B is there, and vector C is there. For this we will have the formulas will be there, and even we find the cross product also with the help of this one. So product of three vectors or it is called as a scalar triple product. Product of three vectors or else scalar triple product. Okay, of, that is vector A and vector B is denoted by like this. We'll write vector A, vector B and vector C, and it is defined as, it is vector A, vector B, vector C. It is equals to vector A dot vector B cross C. Okay. So that means to find this value, triple product, we need to convert it into, that is vector A dot B cross C. So with the help of that, you can find the value of the three vectors. And in this, some conditions are there. That is, those values are, you can take them as a note. Okay. Then there is a triple product of these vectors. Vector A, vector B, vector C is equals to B, C, A. The value of these are same if you do ABC or BCA and next CAB also. Okay, this is one condition. Next one is A cross B cross C, and this is the important one for finding the product of three vectors. Okay, A cross B cross C is equals to, or A cross B cross C, anything. Okay. So that means the cross product of three vectors, it is equals to, this formula is important, that is A dot C, that is into B bar minus B dot C into A bar. This vector A dot C into B minus A dot C into B, next B dot C into A. So you have to split, means that one thing is you can do first cross product of A cross B, then whatever the resultant you will get, that you have to do again cross product with C. Somewhat it will be lengthy process. To shortcut that one, you have to convert this A cross B into cross C is equals to this formula. Here all are dot products, no? So easily you can do the answer. Dot product means you will get the scalar values. So whatever the resultant you will get the, with the help of that, you can, if you multiply that one, the answer you will get, and this whatever right hand side is there or left hand side, both the answers will be same, whether you do in this formula or in this formula. Okay. So, but remember this one, this is the important one for solving the problems. And third one is, that is triad of this is equals to minus. If you interchange any vector from here to there, then you have to put the sign it as negative sign. That is vector A, vector C, and vector B. Or if you write that vector C this side or vector B this side and vector C there, if you interchange the places of any vector, then you have to put it the sign as negative. Okay. And I dot j vectors, if you convert them into the components of the vectors I, j, k, there also conditions are there. I dot j. So if you have like this vectors, instead of A, B, and C, if you have I, j, k, then you can write I dot j cross k. Just now we have seen formula, no? So the triple product of vector A, vector B, vector C is equals to vector A dot B cross C. So here also I, j, k means I dot into j cross k. So what is j cross k? J cross k value is I know. So T is equals to I dot I. So what is that value? The value is 1. Similarly, so if you have j, k, I, so it will be j dot j dot j is equals to, and also next what you will get I, j, k. So j, k, I we got. Now k, j, I. That is k, I, k, I, j. So it is k, next I cross j. So it is k dot k is equals to 1. Okay, these values also wherever you do the triple product, you can remember them. So now we'll find one value of A cross B cross C. So 3 vectors are given, then find A cross B cross C. A is equals to I minus 2j minus 3k, and B is equals to 3i minus 2j plus 4k, and vector C is equals to 4i plus j minus 2k. Then find A cross B cross C. Okay. So we know that A cross B cross C is equals to A dot C into B minus B dot C into A. Okay, this is the formula, you remember. So first one you find A dot C. So vector A dot vector C is equals to, directly I am doing here vector A and vector B. So if you want, you can write them and put the dot product. So 1 into 4 is 4. Next minus 2. Next minus of minus is plus 3 to the 6. So how much will get? 8. Okay. 8 and A dot C into B. So A dot C into B. So 8 into what is B? B is 3i minus 2j plus 4k. Okay. That is, if you multiply, you will get it as 8 3s are 24i. 8 3s are 24i minus 8 2s are 16j plus 8 4s are 32k. Okay. So this is the value of A dot C into B. Next, B dot C into vector A. So B dot C is equals to B dot C. So 4 3s are 12. So minus 2 into 1. So minus 2 minus 4 2s are 8. So this is 10 means we will get it as 2. Okay. This value is 2 and B dot C into vector A. B dot C into vector A is equals to 2 into vector A is this one I minus 2j minus 3. So it is equals to 2I 4j minus 6k. Okay. So for A cross B cross C, we need to substitute these two values and whatever the resultant you will get, that is the answer of the problem. So therefore A cross B cross C is equals to A dot C into B. What is that value? 24I minus 16j plus 32k minus y minus of minus is plus 4j plus 6k. That means 24 minus 2 is 22i minus 16 plus 4 means minus 12j plus 38k. Okay. So this is the resultant vector, and remember that whenever we do the cross product, you will get the resultant as a vector. So this is the vector. So this is the method how to find the cross product of three vectors or triple scalar product. And even if you find the volume of the paralleloid whose edges are given by the three vectors, then we have to find the volume of that one. To find that volume of that, just we have to find the triple product. Just now, whatever we have done, no, that we can find with the help of the determinant also. Find the volume of the paralleloid. Find the volume of paralleloid whose edges are given by the vectors. So first vector is minus 3i plus 7j plus 5k, and second one is 5i plus 7j minus 3. And third one is 7i minus 5j minus 3. Okay. So we need to find the volume of that one. The solution. So we put this one as A, that is let A vector A is equals to minus 3i plus 7j plus 5k. And vector B is equals to 5i plus 7j minus 3k. Next to C vector is equals to 7i minus 5j minus 3k. Okay. So then the volume of the paralleloid is triple product of, that is vector A, vector B, vector C. So that means it is vector A dot B cross C also we can do like that. Our number is equals to, so whatever the coefficients of I, J, K are there in the vectors A, B and C, we can find the determinant of that one. That is -3, 7, 5, 5, 7, -3. Next 7 minus 5 minus 3. 7 minus 5 minus 3. So volume means we need some value, no? So before problem we have whatever the A cross B cross C is there, that we got as a some vector. Here he is asking the volume of the parallel point. So for that one we need some scalar value. So that's why we are doing with the help of the determinant here. So if we find the determinant of this one, this is equals to -3 into -21. Minus into minus plus again minus, so 5 is a 15, minus 7 into 5 is a minus 15 plus 21, plus 5 into 5 is a minus 25, minus 7 7 49. So it is equals to -3 into, so minus 36, minus 3 into minus 36. Minus 7 into, we will get as 6 plus 5 into 1, 4, 5, 6, 7, 7. So this is 108 minus so plus 108 minus 42, and this is minus. So this is minus again. If you do, you will get it as this is minus. So minus 370. So if you add and do the subtraction, you will get it as 304. So volume, so you can write it as cubic units. Volume of that is volume V is equal to 304 cubic units. So like this you have to find the, so these are all the 5 marks questions. So next many more example problems are there and some other different topics are there in the unit 1. So try to follow from the textbook. Worked out exercises are there, examples are there, check your progress are there, and different problems, MBQ questions are also there. Okay, see from that. Next we are going to the unit 2. So unit 2 is about the differentiation of vector point functions and also curves and tangents and arc length. So in this differentiation is introduced of the vector function. We know already what is the differentiation. So any function will be given, you have to differentiate that function with respect to x. So here we are doing the differentiation for the vectors. So vectors will be in the form of xi plus yj, that is vector xi plus yj plus zk form will be there. So for that functions, we need to find the differentiation of that one. So first one, scalar function means you will not have the vectors, that is I, j, k will be not there. Only the function will be in the form of just like this, f of t is equals to, so you have the definitions in your textbook. Differentiation of vector point function. So first definition is there about the scalar point function. Scalar point function means you will have the function in the form of f of t is equals to like this 2t plus e to the power of t. Here I bar or j bar, both are not having the vectors. So whatever the function is there in this form, this is called as scalar point function. Next one is vector point function. And in between some intervals, they will have the functions. So that will be in the form of f of t is equals to t square I minus 2t j bar plus e to the power of t k bar. So this is the vector point function. So like this, if we have the functions, then we call, and the t, whatever the t value is there, that here belongs to the closed interval. Here also t belongs to some interval there, closed interval 0, 1. Okay. So here f of t is here vector function, and that f of t is the scalar function. Okay. So on this, you will have the vector point function will be there, and also scalar point functions, and vector function, and vector that is the scalar functions. Okay. So on this, you will have the concept of the differentiation. So the heading of unit 2 itself is the derivative of a or differentiation of a vector function. So any vector will be given, to that we have to do the differentiation, that is df. We'll put the vector sign on f, vector f by dt, or we'll write it as f dash of t. Similarly, how we'll do normal differentiation, same like that only. So derivative of a vector function. Derivative of a vector function means it is d by d with respect to of t we are doing. So it is equals to, if you see the normal definition of this one, limit delta t tends to 0, vector f plus t plus delta a. So we have the derivative formula now, limit h tends to 0, f of x plus h minus f of x by h. So like that, here also you have the formula for the derivative of a vector function, minus f of t by delta t. Okay. So this is the standard derivative of function definition. Okay. So r df by dt, we call it as a f dash of t. We'll write normal f dash of t here. Above you will have the sign of the vector. Okay. So f dash of t or df by dt bar, that is called as a derivative of a vector function. And for this derivative of a vector function, you have the rules are there, some rules. So these you will get for the objective type. Rules of differentiation. Okay. So rules of differentiation is, first one is, that is dc by any constant vector if it is there. So for the constant vector, when you do the differentiation, you will get the answer as 0. And second one is, if you have the vectors, two vectors, d by dt of f is one vector, g is another vector, and you plus or minus, we are doing either addition or subtraction, you will get it as d plus or minus d by dt. Okay. And if you do the multiplication also, multiplication means UV rule, we have d by dt of f of t into g of t. So f of t take constant, then dg of t by dt plus vector g of t, if you take constant, then d f of. So UV rule we have now in differentiation, the same rule will apply here. So this is about the dot product. So whenever you have a cross product, instead of dot, you have to put the cross here. The rules are important for solving the problems. Next, fourth one is d by dt of f of t cross g of t. Okay, that is the cross product of two, means you will get it as cross dou. Okay, plus g cross This is for the cross product. If any in place of G, if you have pi d by dt of pi of vector f, then it is pi into df by dt plus d pi by dt into f. Okay. And this last two rules of differentiation you can see even from the textbook. See 6th and 7th rules also. They are somewhat very big one. So proofs are also there for these all. For all these rules, how you are getting them, the proofs are also given in the textbook. You can see from this. Next we have the Fermat-Sernet formula is there. So Fermat-Sernet formula, it is useful for the to find the torsion or else radius of curvature or curvature. So some one question you will get on this also. That is how to find the in the question itself they'll ask to find the torsion of the given vector or find the curvature of the vector or else radius of curvature or what is the Fermat-Sernet formula. So proof is there for the Fermat-Sernet formula. You can see from the textbook. Just the identification of some points is enough here. So what is the torsion, what is the radius of torsion, and also what is kappa, and what is the rho value, and what is the curvature value, what is the principal normal, and what is the binormal is there. That all definitions you have in the textbook. So if you remember them, and what is the t value, so in the textbook it is there. I am not going depth into there. And here, whatever the values are there, you write that one. So here, whatever the symbols we use, I am writing here. So Fermat formula. Okay. So on this first one is T will be there, capital T. On that, if you put the cap, it is a unit vector. T, whatever it is there, it is the unit vector along tangent. Is unit vector along tangent. Next, if you have the vector n, it is n cap. It is unit vector along principal normal. Okay. Next one is B will be there, capital B. That is a unit vector along binormal. And here we use some symbols are there. The symbols are, this is tau, you call it as. Okay. This is called as tau. This is called as torsion. This side way. Okay. And this is called as rho. And it is radius of curvature. And curvature is called as kappa. It is land there, right? This is called kappa. This is curvature. Okay. And here this what is radius of curvature is there. After that you have sigma is there. And after that sigma value like this. This is sigma. And sigma value is equals to 1 by torsion. So these are the identities which we are using in Fermat-Sernet formula. And for this, what is T, how is T defined, how is N defined, and also how is B defined. That all definitions you have in your textbook. You can see that is T is equals to this whatever vector T is there. This value is dr by ds. Okay, dr by ds, and N is there now. N is the unit vector along dt by ds, and N is called as a principal normal. Okay, at point B to the curve, and kappa is equals to dt by ds. This k is there. No? One more is, I hope so you written this. So with the help of this all, dt by ds, it is equals to kappa k into unit normal n. Okay, and this is called as a curvature of the curve at the point, and its reciprocal is equals to 1 by kappa. This is called radius of curvature. Okay, this value is the radius of curvature. And next we have in between another one important one is what is torsion defined as. Torsion is defined as that is modulus of torsion is equals to and dB by ds. All definition whole theorem proof is there in the textbook. Just I am giving the important notations here. Okay. Torsion into n bar. We need these values dt by ds, dB by ds, and also another one is dn by ds. What are those values? Those three values are called as the main Fermat-Sernet value is defined from these three values. Okay, is equals to minus. If mod is there means mod torsion is equals to dB by ds. Okay. O is called the torsion, and here whatever the sigma value is there, sigma is equals to 1 by torsion. This is also important. This is called radius of torsion. This is it. And another one is dn by, we got this value, this value. Now second value is dn by ds. This is equals to, that is torsion into b minus kappa into e. Okay. This is the definition of dn by ds, dt by ds, and dp by ds. So this one and here whatever it is, this one and this one. These three are combined, it is called as a Fermat-Sernet formula. Okay. So if you remember them, problem will be asked to find what is the radius of curvature, and to find the torsion it will ask, and to find the curvature, and also to find the value of dn by ds. So in one question only, you will ask to find these all values. So one, you may get the 10 marks problem on Fermat-Sernet, these all identities. With the help of this, one question will be there, three, in that only three sub questions will be divided. So they will be combination of all that, and it will be asked for the 10 marks question. Okay. See the example problem from your textbook, and these whatever three equations are there, so for your identity I am putting this one, this as 1, and this is 2, and this is 3. So these three equations are called as a Fermat-Sernet formula. Okay. So Fermat-Sernet formula, even it is defined in another way also, that is there in your textbook. See that one in that is omega, in the form of omega also it is divided. So it is defined in the form of omega also. Omega it is equals to torsion into T plus kappa into B. So then you will get again three equations. So the three equations is also combination of the dB by ds, dn by ds, and also dt by ds. Okay. So that is defined with the help of the omega. That is also another form of the Fermat-Sernet formula. Okay. You see that from your textbook. On this also you have one example problem. So in this year, first one we have seen about the differentiation. Next even we have the partial differentiation. So partial differentiation means, you know, instead of D, we write it as a dou, that is dou f by dou x, dou f by dou y, and we'll do with the help of the variable itself. So partial derivative of the function also, you have the definition is there, and also rules of partial differentiation is also there. It will be as similar to the differentiation only. Just we have seen some rules now. Similar way it will be there. Partial derivatives, how to write means partial derivatives of a vector function. So function, any vector will be given as f bar x comma y comma z. Okay, be a function of three independent definition is there in your textbook. See, of three independent scalar variables x comma y and z. Then first order partial derivative of this. Then first order partial derivative of f with respect to x is defined as, I will define that one. That is f, we'll write here base x more. Partial differentiation, it is equals to dou f bar by dou. Like example we write. Okay, so if it is with respect to y means f to the base y, dou f by dou y. If it is with respect to z means, we'll write it as f z is equals to dou f by dou. These are the first order. If it is a second order means, we'll write this as f xx and f yy. Next f zz. Third order, so on, we'll write up to nth order. Okay. So like this, how the representation will be there, that is important, and how we'll find the partial differentiation for the given vectors. So one small problem we'll see on this, and we'll wind up the class. So if f is equals to 1 minus cos t y plus t minus sin t into j, then find df by dt, df by dt, and also d square by, that is the differentiation. Okay, dt square. So solution f is there. So if we find df by dt means differentiation of that one with respect to t. So one differentiation is 0 minus cos t. Cos differentiation is minus sign. So minus of minus means plus sin t. Next here t differentiation is 1 minus sin differentiation is cos t into j bar. This is df by dt. Next d square f by dt square. So you have to do one more time differentiation. So sin means you will get it as cos t I bar plus 1 differentiation is 0, and cos means minus sign, minus of minus is plus sign. So sin t j bar. Okay. So like this we have to find the differentiation of the any given function, first order, second order, or third order, or nth order. Similar way you can find the partial differentiation also with the help of this. So some example problems are there in your textbook. And any particle moves along the curve whose parametric equations will be given x, y, z. So you have to find the velocity and also acceleration. The question will be also there. These questions you will get for the 5 marks question. Tomorrow we will see that one.